Welcome. Today, we're going to crack open the digital toolkit that powers pretty much the entire modern web. Yep, we're talking about JavaScript. We're going to demystify the core tools that bring all your favorite websites to life.
I mean, have you ever really stopped to think about it? You click Add to Cart, and boom, the little icon updates instantly, no page reload. Or you log into a site and it says, "Hey, welcome back." How on earth does it do that?
It sure feels like magic, right? But it's not. Behind all that seamless, snappy interactivity is JavaScript. It's the engine working away behind the scenes, managing all the information and creating those dynamic experiences we just expect now.
So, to really get how it all works, we're going to build our own foundational toolkit together. First, we'll talk about the why, the problem we're trying to solve. Then we'll look at the containers for holding info, the materials we can put inside them, and of course, the action tools we use to make things happen. And by the end, we'll see our fully assembled kit.
Okay, so what is the core problem here? Well, we want our websites to be more than just static pages of text and pictures, right? We need them to react when you click a button, to handle data, and to change what's on the screen. And that requires a system for managing information. That's where our toolkit comes in.
First things first, if you're going to work with any kind of information, you need a place to, well, put it. This brings us to the very first, most fundamental tool in our kit, the containers. In the world of JavaScript, we call these variables.
And it really is that simple. Just picture a labeled box. You give the box a name, you put something inside of it, and then later on, you can just use that label to see what's inside, or even swap it out for something else.
Now, JavaScript gives us 3 different keywords to create these boxes. The modern tools, the ones you'll use most of the time, are let. That's for boxes where the contents might change, and const, for when you're storing something that you promise is never going to change. Then there's var. That's the old school way. It's a bit more flexible, but honestly, that flexibility can cause some really weird bugs, which is exactly why let and const were created.
This little chart here breaks down the big differences, and the most important one is this column called scope. Think of scope as the room where your box exists. With let and const, they have block scope, which means the box only exists inside the specific chunk of code, between those curly braces, where you made it. This is amazing for keeping your code clean and bug-free. Var, on the other hand, is visible throughout an entire function. This can cause some nasty surprises where a variable kind of leaks out and messes with something you didn't mean it to. It's a classic gotcha. And of course, as you can see, you can always change what's inside a let or var box, but a const box, once you put something in, it's locked.
Okay, so we've got our containers. Awesome. But what kind of stuff can we actually put in them? Well, that brings us to tool number 2, the materials, or what programmers call data types.
These are the main materials you'll be working with. You've got numbers for any kind of math. You've got strings, which is just a fancy word for text. Then you've got Booleans, which are super simple, just true or false. And then we have these 2 special ones, Undefined, which is basically the state of a box you've made but haven't put anything in yet, and Null, which is when you deliberately decide that a box should be empty.
And this one trips up everybody at first. So let's get it straight. Undefined is the computer saying, hey, this box exists, but you haven't put anything in it. Null, on the other hand, is you telling the computer, I'm intentionally making this box empty. It's the difference between accidental emptiness and deliberate emptiness.
So we have our containers, and we have our materials. Now for the really fun part. We need tools that actually do things. Tools that can do math, move data around, and make decisions. These are our operators.
First up are the ones you totally recognize from math class, arithmetic operators. These are your basic calculator functions. You can add, subtract, multiply, divide. You can even get the remainder from a division or do exponents. Simple, straightforward, and super powerful.
Next up, we have our data movers. The single equal sign is the most basic one. It just assigns a value to a variable. It says, put this thing in that box. The others are really just convenient shortcuts. For instance, plus equals adds a value to whatever's already in the variable and updates it all in one go. It's like saying, take what's in the box, add 5, and put the new total right back in.
Okay, now this is where your code starts to get smart. Comparison operators are your decision makers. They compare 2 things and give you back a Boolean, a simple true or false. Is this number bigger than that one? Are these 2 pieces of text exactly the same? The answers to these questions are what let your program make choices and change what it does.
Okay, everybody lean in for this one. This is maybe one of the most important things for any new JavaScript developer to get right.
The double equals is kind of lenient. It tries to be helpful by converting things of the same type before it compares them. So to double equals, the number 10 and the text 10 look the same. But the triple equals is strict. It checks both the value and the data type. No funny business. To triple equals, the number 10 and the text 10 are completely different things. Pro tip, just always use triple equals if you can. It's way safer and will save you from some serious headaches down the road.
And finally, we have our connectors. Logical operators let you chain multiple true-false conditions together. The and means both things have to be true. The or means at least one of them has to be true. And the exclamation point, the not, just flips a Boolean. So true becomes false, and false becomes true. And just like that, we did it. We've assembled a complete foundational toolkit. You've got your containers to store information, you've got different materials to work with, and you've got a whole set of action tools to actually manipulate all that data. So the whole blueprint, the basic workflow, really just boils down to these 3 simple steps. First, you create a container, a variable, to hold something. Second, you know what kind of stuff, what data type you're putting inside it. And third, you use your operators to make stuff happen. That's the core loop of programming.
And this is why this all matters so much. Every complex app, every mind-blowing animation, every cool interactive feature you see online, it's all built on top of these simple core ideas. Mastering these tools isn't just the first step, it's honestly the most important one.
So there you have it. You've got the foundational tools right in your hands now. Your containers, your materials, and your action tools. From here, the journey gets even more fun with things like functions and loops and objects. But for right now, the real question is, what are you going to build first? The possibilities are all yours.